Okay, so in this question we're given two speakers that are placed a certain distance apart, and we're asked to find the number of points where destructive interference is observed along a circle with a radius of 1 meter from the midpoint of the two speakers. So before we get into the problem, I first want to go over a concept called path length difference. So in this diagram right here, we have two speakers projecting sound to the position at the red X. Now let's suppose that the sound that's projected from each speaker has a wavelength of 2.5 meters. Now the distance that the sound has to travel from its source to its destination is what we call the path length. So in this case, the source would be one of the two speakers, and the destination would be the red X. So the path length for speaker 1 would be this distance right here. And the path length for speaker 2 would be this distance over here, which we're going to denote as x2. Now the path length difference, which I'm going to denote as delta x, is simply the difference between these two path lengths. So it's going to be the difference between x1 minus x2. So hypothetically, if we said that the path length for the sound produced by speaker 1 was equal to 10 meters, and the path length for the sound produced by speaker 2 was 5 meters, then the path length difference in this case would be 5 meters. Now path length difference is relevant to our problem at hand, because if the path length difference is equal to a multiple of the sound's wavelength, then we'll get constructive interference at the red X, or at the destination. On the flip side, if path length difference is equal to a multiple plus 0.5 times the sound's wavelength, then we'll get destructive interference. So in this case, our wavelength is equal to 2.5 meters, and our path length difference is 5 meters. And because our path length difference is a multiple of 2, so m is equal to 2, of our wavelength, we'll get constructive interference at our red X. Okay, so now let's take a closer look at our actual problem. So we're told that the frequency of the sound emitted by the two speakers is equal to 680 hertz. We're also told that this sound is traveling at a velocity of 340 meters per second. So using the equation velocity is equal to wavelength times frequency, we can find that the wavelength of the sound being emitted is equal to 0.5 meters. Now let's plug this calculated wavelength into our destructive interference equation over here. So we would end up with path length difference is equal to m plus 0.5 times 0.5. Okay, so if n were to be equal to 0, we're to plug 0 into m right here, then we would obtain a path length difference of 0.25 meters. Now if m were to be equal to 1, then we would obtain path length difference equal to 0.75 meters. And we're going to do the same thing if we were to plug 2 into m. We would get a path length difference of 1.25 meters. And recall that m has to be an integer value. And so we can continue doing this with m is equal to 3, m is equal to 4, m is equal to 5, all the way to infinity. But we're going to stop here. So these are the path length difference values for which we will get destructive interference in this problem. Now let's turn our attention over to the actual setup of the two speakers and the listener. So the two blue dots I've drawn in this diagram right here represents the two speakers, whereas the green dot represents the listener moving along a circular path around the two speakers. Now the point right here represents the midpoint of the two speakers. The problem states that the listener is walking in a circle of a radius of 1 meter from that midpoint. So you can see that distance between the listener and the midpoint is 1 meter. And we're also told that the two speakers are spread a distance of 1.5 meters. So it makes sense that each speaker is 0.75 meters from the midpoint. Now if the listener were to be at the green dot that I've drawn here, then the distance that the sound would have to travel from speaker 2 to the listener would be 1.75 meters. So the path length of the sound produced by speaker 2 would be 1.75 meters, whereas the distance that the sound would have to travel from speaker 1 to the listener would be 0.25 meters. So the path length of the sound produced by speaker 1 would be 0.25 meters. So in this case, our two path lengths are 1.75 and 0.25. And so at this position, at the green dot right here, our path length difference would be 1.5 meters. Now if the listener were to be at this gray point up here, he would be equidistant from both speakers 1 and 2. So in other words, the distance that the sound would have to travel from speaker 1 to the listener at the gray point would be equal to the distance the sound has to travel from speaker 2 to the gray point. So at the gray point right here, path length of speaker 1 would be equal to path length speaker 2. Another way you can think of it is that these 3 points form an isosceles triangle. And so these two distances over here are equal to one another. So in this case, at the gray point, if the listener would be at the gray point along the circumference of the circle, the path length difference would be equal to 0 meters. Now as our listener moves from the green dot to the gray dot, the path length difference that he experiences is going to decrease. So when the listener is at the green dot, path length difference is 1.5 meters, but then once he gets up to this point right here, path length difference might decrease down to 1.25 meters. As he moves further along the circle, might go down even more to 0.75 meters, and when he's nearing the gray point, it's going to be maybe at 0.25 meters. And then finally, when he gets to the gray point, path length difference is going to be 0. Now recall that these 3 values here were our path length different values for destructive interference. So at these points, our observer is going to experience destructive interference. So from going across the first quadrant of this circle, our observer is going to experience destructive interference at these 3 points. Now the same thing can be found when the observer moves through the second quadrant. And so in this case, our observer starts at the gray dot up top, and then he might move down to the blue dot I'm drawing right here. And at this blue dot, the path length difference is going to be just like what it was at the green dot. It's going to be 1.5 meters. So as our observer moves from gray to blue dot, he's going to again experience a point where path length difference is 0.25 meters, where it's going to be 0.75 meters, and then a point where it's going to be 1.25 meters. So going through the second quadrant, our observer is going to experience 3 more points of destructive interference. And this is going to happen on the other side of the circle as well. So down here, he's going to experience another 1.25 meters. As he gets further away from the circle, it's going to increase. And when he gets near the bottom of the circle, it's going to be 0.25 meters. And the same thing is going to happen in the last quadrant as well. And so here's 0.25. And so in total, our observer is going to experience destructive interference at 12 points along the circumference of this circle. And that is the answer.